Hello, kids. How are you today? Today we're going to talk about rhombus. And definition for rhombus is that it's parallelogram with all sides congruent and opposite angles congruent. So let's begin. If I drew the line, it's about AB, and I label it A and B. I decided that my congruent side will be 6 centimeters. So to draw a rhombus, you need a size of one length, which is 6 centimeters. So I can put 6 centimeters. And then I also need at least one angle. So I'm going to pick, let's see, 110 degrees angle. So I'm going to put my compass protractor right there on point A, and here is the outside is my 0. So I'm going to go all around, and I will maybe have a 110 degrees, so some point right here. So this is going to give me 110 degrees around point A. So I can track that if you would like to see how it looks like. The angles are in a circle. So the angle that forms around point A is this angle right here. And as now I measure that to be 110 degrees. Things that I know about my rhombus is that this angle over here, opposite to it, is going to be also 110 degrees. And I know the rhombus is parallelogram, so I can use a parallel lines and extend this line to be 6 centimeters. Here we go. It's like till here, that's a 6 centimeters. And there is going to be my point. And then I also can take my parallel line. If I take my 2 triangular rulers, I can put my green ruler parallel to a point, this line segment, and have my orange to be next to it. I will keep the yellow very sturdy, and then I will just slide my green toward the point B, and I will draw my parallel line that is parallel to this line. So now I need to measure how long is that my line. It's going to be 6 centimeters, and it's about this right here. And then I can also connect AB to the other side and slide and connect to. I just lost it a little bit, so I'm going to go back, keep the yellow sturdy, and then just move slightly with one finger the second triangle till I reach the points. Then I'm gonna connect. So here we go. I created rhombus, and I can prove my sides to be congruent. 6 centimeters is A, B, C, and D points. So A, B, C is 6 centimeters, as you can see, and CD is also 6 centimeter. And then AD is 6 centimeters. So all the sides congruent. So now I can prove that the angles are the same, and I know they are. I can use my compass and I can make semicircle. I'm going to do also for point B and for point D. Okay, to help. And I can tell you that these are the point is also 110 degrees. And then since I know, then these are congruent and they are 110 and 110. The opposite sides are opposite angles are congruent. These two will create 220 degrees. So B and D are going to share rest to the 360 degrees. So what number plus will equal to 360 degrees? So we know then there's going to be a 0, and then here is missing 4, and to get 300. So these two must share 140 degrees. Since they also must be congruent, they are going to be 70 degrees because 140 divided into 2 is 70 degrees. Okay, so now we can see and we can prove it by using our protractor, and we're going to measure. If my point is on D, my 0 line is DC segment, I go inside measure, so 10, 0 is line, this line is 0, 10, 20, 30, 40, 50, 60, and then my AD segment is exactly on the 70 degrees. So that is a true statement. So that is 70 degrees. I also color my angle so they can see visually. And this one is 110 degrees. And this one is also 110 degrees. So, and then let's see that on this, the angle around B is the center is B is 70 degrees, and then this one is also 70 degrees. So we can then we can say that there are 4 sides, so we can start counting so that there is a 4 congruent sides. Okay, and when we explore angles, we have 4 angles. We have a two congruent and opposite, two congruent obtuse, and two congruent acute angles. Okay, so these are, we can label acute, and these are obtuse angle, and they are opposite. Okay. The diagonals, we can explore diagonals. So there are 2 diagonals and they are perpendicular. How we know they're perpendicular is that they cut each other under the 90 degrees angle, and we can prove it. Here's a diagonal one, and we can prove it with maybe paper sticker. It has a 90 degrees angle, and you can see that it fits perfectly, and that is right 90 degrees angle. So two diagonals are not congruent, but they are perpendicular to each other because they bisect, and they cut each other in right midpoint is a right angle, straight right angle. So two, and we can say two perpendicular diagonals. Okay, we can label our sides. So, for example, if we're gonna label AB segment is a congruent, is this little equal sign with wavy line on the top. That means congruent. AB segment is congruent to BC segment, and the BC segment is congruent to CD segment, line segment, and then CD is congruent to the DA line segment. Okay, and then all these are equal to 6 centimeters. We can also say that angle BAD is congruent to the angle BCD. I forget to put the angle sign, and they are both equal 110 degrees. Okay, we can also, some people label just that, like angle B, because it's in a point, share that point, is congruent to the angle D, and they're both equals to 70 degrees. Okay, we can say that diagonal one, it's D1, and D2 is perpendicular, is upside down T with the diagonal 2, and they're not congruent. We can also measure our diagonals if we wish to. So this could be about 7 centimeters. So diagonal 1 is equals to 7 centimeters, and diagonal 2 is till here is 7, 8, 9, 9.7 centimeters. So diagonal 2 is 9.7, 9 and 7 millimeters, 9 whole centimeters and 7 millimeters, or 97 millimeters if you will like to talk like that. We can explore symmetry. And we can use, thinking about symmetry is having this shape, it's a rhombus. If we can cut rhombus into the two equivalent parts, then we have a line symmetry. So I already prepared this little rhombus. So if I cut rhombus in lines like this, that would be my one line of symmetry, which is one of diagonals as well, but we can prove it by flipping that, and it will exactly make half of our, and it's not overlapping, so we create one line of symmetry. Another line of symmetry is another diagonal of the rhombus, and if I do this also, I can flip the shape rhombus across this diagonal, and you will create two halves. So that means this is a line of symmetry as well. So that would be a two, so far two lines of symmetry. If I try to do this way, you can see then it doesn't work because it's overlapping. So that's not symmetry. This cannot be line of symmetry because they are not equivalent parts that are into that the line symmetry will create. So we can conclude that this is L1 and this is L2 as well. So two line of symmetry. Okay. The last thing that we can explore is rotational symmetry, and it's important. We can draw the we can patty paper or see-through paper. Then we can use if we trace our rhombus, and we just put the dot on the top, like here, so we know where we start. If we hold the paper in the middle, so we will rotate through to the center of the shape. We can rotate the shape to 90 degrees, and it's not get into the same shape. But when we go and rotate 280 degrees, it comes to the shape. So that is one rotational symmetry. And then we keep rotating because our dot is on the bottom now. Intention, if we do 275, and then finally when we come back to the 360 degrees all circle, we got twice stop. So that means that rhombus has a two rotational symmetries. Two rotational symmetry. And this will be about rhombus. I hope you learn from me. Thank you for watching. Appreciate that. Okay, see you next time.